Hello everyone. Today we are going to solve some of the numerical based on tension member by LSM method, that is your limit state method. Today we will solve numerical type 1, that is to find the critical plane of failure and effective net area of the tension member. We have the questions. The question says that a 300 mm plate of thickness 8 mm of grade Fe410 is used as tension member in a lattice girder. It is connected to a 12 mm thick gusset plate by 18 mm dia bolts of grade 4.6. Calculate the effective net area of the member if it is chain bolting, and second case says if it is zigzag bolting. So in both the ways we have to find the net area. Let's start with chain bolting. In chain bolting, as the diagram says, that chain bolting will have the three planes: this or this. Since it is all symmetrical, or we can say identical, so the critical plane will be any of these bolt alignment, and it will be always perpendicular to the force. So we have the basic formula, that is AN, that is equals to width minus number of bolts into dia of holes into thickness of plate. So B is the width, of plate, and it is given as 300 mm. So 300 mm minus n, number of bolts coming in this plane, that is 1, 2, 3, 4, into DH. What is DH? DH is dia of hole, and it is calculated by adding clearance to the dia of the bolt, original dia of the bolt, that is nominal dia of the bolt plus clearance. So 18 plus 2. If you have to know about the clearance, you can reference IS code. 18 plus 2, that is 20 mm. So DH will be 20 mm into thickness of plate. Thickness of plate says 8 mm. Question says 8 mm. So 8. Therefore, on solving this, we get 1760 mm square. Thus, if question says calculate the effective net area, then we should realize that effective net area, that is ANE, has the relation with net sectional area, that is K1, K2, K3, K4 and AN. Here K1, K2, K3, K4 are ductility factor, hole forming factor, geometry factor and shear lag factor. Since question does not give this account, so we consider this K1, K2, K3, 4 and K4 as 1. Therefore, effective net area will be equals to 1 into AN. Therefore, in chain bolting, effective net area will be equals to 760 mm square. Thus, we can say that in chain bolting, this plane is the most critical plane since it is very close to the end. On account of zigzag bolting, the formula we will use will be AN equals to B minus N DH plus N dash pitch whole square 4 into gauge into thickness of plate. For zigzag bolting we will use this formula for obtaining the net sectional area. First we have to consider different planes of failure in which the tension member can fail. So let us consider first plane. Suppose we assume that first it will fail along this plane. Then we consider that it should move from this bolt to this bolt, and sudden it goes to this bolt, or it may travel from this bolt to this bolt. So first we nomenclature the points of this plane. At the end we consider this as 1, this second, this third, and this end fourth, this 5, 6, and this 7. Similarly, if this plane move to this bolt, we will consider this as 8 and this 9. So first we will see what is the possibility of the critical plane which may arise. So considering different planes, the first plane may go like this, that is 1, 2, 3, 4. Second plane may go like this, 1, 2, 5, 3, 4. Third plane may go like this, 1, 2, 5, 6, 7. Fourth plane may go like this, 1, 2, 5, 8, 9. In this all the plane which will give the least area will be considered as critical plane. Out of this 4 plane, the plane which will give the least area will be considered as critical plane of the member. So first we have to find net area for all this plane, considering the first plane. First plane 1, 2, 3, 4. So we will use the formula, this same formula. AN will be equals to B minus NDH plus N dash P square 4 into G into TP. So it will show 300 minus N. We have to count the bolts in the plane which we are considering. So there are two number of bolts. You can see that 2 here and 3. There are only 2 bolts. So at N you have to put 2 into 20 plus N dash. N dash is your staggering. Staggering means if the plane is staggered from its path, the number of times it staggers gives N dash. So since this plane is a straight line, it does not stagger, therefore N dash is equals to 0. Therefore this formula comes to this, that is 8 mm. On solving, it gives 2080 mm square. mm square. Okay, now we will consider second plane. Second plane, that is 1 2 5 3 4. You can see that this plane moves in different way, not in straight way but in different way. 1 2 5 3 4, then it clears. So we can see that this plane is staggered 2 times, that is from 2 to 5 and 5 to 3. Here you can see that this plane has been staggered 2 to 5 and 5 to 3. That is number of times, that is 2 times it has staggered from its path. Therefore N dash will be equals to 2. Therefore AN will be equals to 300 minus, now N, that is number of bolt. Number of bolt here is number of bolt here is 1 2 3. You can see that 1 2 3. 3 number of bolts into dia of holes, that is 20, plus staggering is 2 times. Staggering is 2 times. Therefore 2 times into pitch square, pitch ka square, that is pitch is 65 here, pitch is 65, 4 into G, that is gauge is 75. I have told you about the pitches and gauges earlier in the classes. Into thickness of plate. On solving this, AN comes 2145.33 mm square. Similarly, you have to find net area for the plane third and fourth. Third plane, that is 1 2 5 6 7. Again same formula, 300 minus n. In this we have to first see how many of number of bolts are coming in its path. So 1 2 5 6 7. So number of bolts in this path is 1 2 and 3. Plus, now how many times it has been staggered. So you can see that it starts from here and is staggered only one time, then it has followed again the straight line, staggered from 2 to 5. So n dash is 1 into pitch square, that is 65k square, upon 4 into 75 into thickness of plate, that is 8 mm. On solving this, An comes 2032.67 mm square. Similarly, we have to solve plane fourth. That is 1 2 5 8 9. That is 1 2 5 8 9. So you can see that it has staggered from 2 to 5, then 5 to 8. Therefore, An will be equals to 300 minus number of bolts coming in this plane, 1 2 3, only 3, into 20 plus staggering. You can see that staggering is 2 times, that is from 2 to 5 and 5 to 8. Therefore, on solving this, it is again showing 2145.33 mm square. Thus, the least area will be considered as critical plane. So, first plane is showing 2080 mm square. Second plane is showing 2145.33 mm square. Third plane is showing 2032.67 mm square. And fourth plane again showing 2145.33 mm square. So the second plane is showing the minimum area. Since second plane is showing the minimum area, therefore it will be considered as the critical plane for this section. Thus, effective net area will be equals to 2032.67 mm square. At last, if this question comes in your exam, you have to show this critical plane with different color or you can use pencil. So it will start from 1, then it will go at 2, then again 5, then it will go directly to the 6th and it will pass through 7. So this plane will be the critical plane. So guys, I think this video will help you in solving such questions. So thank you friends, and those who want to continue this class in the YouTube channel, you can subscribe, share and like. Thank you.